water is the source of human life. However, only 0.8% of the world's water resources are directly available for use. Throughout the development of civilizations, countries have actively sought headwaters and studied methods of water extraction, storage, purification, and distribution for public use. As early as 3000 BC, ancient Egyptians constructed canals to transport water to farmland and villages, providing drinking, washing, and firefighting water for the people. By 2500 BC, Egyptians, Persians, and Chinese had learned how to drill wells for water extraction. By 2350 BC, well-functioning water storage facilities had appeared in the Mesa Verde in the southwestern Americas and Syria. In the 9th century BC, the Romans began constructing stone aqueducts, which were the ancestors of the modern world's water supply system, bringing running water into homes. In 1606, in Edo, Japan, the city relied solely on the Koishikawa aqueduct for drinking water, which proved to be insufficient. Therefore, Tokugawa Ieyasu ordered the Asano clan to construct a dam and reservoir to store water, ensuring an adequate supply of drinking water for Edo. This dam, called Torainoman Dam, became Japan's first multipurpose urban reservoir. In 1652, the United States built its first water supply system in Boston, including a 12-square-foot reservoir to store spring and well water, making it the earliest country to establish a water supply system. In the 1800s, residents of London relied on water from the River Thames. However, during that time, due to the poor water quality, it led to the spread of disease, resulting in the deaths of thousands of people. In 1829, the Chelsea Waterworks Company established a slow sand filtration system, providing treated water for the first time to the residents of London. This system became the standard for water purification in the United Kingdom. In 1872, 10 Yokohama merchants in Japan jointly established the Water Supply Company. In 1883, the governor of Kanagawa Prefecture hired British consultants to assist in the construction of iron water pipes for a water supply system in Yokohama. In 1887, using the upstream area of the Sagami River as the headwater, a water canal approximately 44 kilometers long was constructed, marking the earliest modern water diversion project in Japan. In 1875, the Yangshupu Waterworks in Shanghai is China's earliest water plant, funded by the firm Little and Company. However, its water supply was limited. Later, the plant was acquired by a British company and renamed the Shanghai Waterworks Company Limited. It began supplying water in 1883, serving approximately 170,000 people. In the early Qing Dynasty, immigrants settled in the plains and formed communities. However, the unclean drinking water led to the spread of epidemics. During the Qing Dynasty, Liu Ming-chuan recognized water as part of public health and hired Japanese technicians to introduce drilling techniques using the iron rod well digging method. This provided clean water for nearby residents and became Taiwan's earliest public water supply facility. The term suedo in Japanese refers to water facilities for daily use, and since tap water is delivered through water pipes, tap water in Taiwanese dialect is called sui-do-sui. During Japan's 50-year rule over Taiwan, 122 water supply projects were completed, serving 1.42 million people and achieving an 18% penetration rate, even higher than Japan's water supply penetration rate during the same period. The process of delivering tap water from the headwater to each household involves several steps. Water intake. Initially at the headwater, water is drawn using a pump and conveyed into the aqueduct. Water conveyance. The water from the source is transported through the aqueduct to the water treatment plant. Water treatment. After the raw water enters the water treatment plant, it undergoes a series of purification processes, including mixing, coagulation, sedimentation, filtration, and disinfection to remove impurities and bacteria. Water distribution. Once the water has been treated and disinfected, it is distributed to various consumers through a network of pipelines. Additionally, a tall water distribution tower can also be constructed, equipped with pumps to draw water from a clear water reservoir into the distribution tower, and then the water can be supplied to the city for use. The development of Tamsui's port and town is closely related to the navigation of the Tamsui River. The Tamsui River is the third largest river in Taiwan and serves as the most convenient waterway for navigation in the country. It encompasses the entire Taipei Basin, with a network of rivers primarily composed of the Darhan River, Xindian River, and Qilong River. This river system forms the transportation network for the Greater Taipei area. As a result, many ports and towns have developed along the main tributaries of the Tamsui River, becoming a crucial hub for people's movement and the distribution of goods. Tamsui, located on the north bank of the river mouth, is the only outlet of this navigable waterway, making it the gateway to northern Taiwan. In the late Ming and early Qing dynasties, it was a crucial waypoint in the competition among maritime powers for trade routes between major powers in the South Seas and East Asia. After the mid-Qing period, it became a transshipment port for immigrants and commodities between the Taipei Basin and the coastal regions of China. After the opening of the port for foreign trade in the late Qing dynasty, it became Taiwan's largest international port. At the beginning of the Japanese colonial period, Tamsui lacked clean drinking water, and diseases such as cholera and dysentery were prevalent, with extremely poor sanitation conditions. In 1896, the head of Tamsui branch, Okubo Torsher-take, hired Danish engineer E. Han Sun to survey two springs at the foot of Dartun Mountain, Shuangjuntou and Shuangjuntou. It was believed that both headwaters emerged from deep within volcanic rocks, and unless there was a significant crustal change, the spring's water quantity remained constant, and the water quality was excellent, suitable for direct consumption. During the late Qing dynasty and the early Japanese colonial period, the area around Shuangjuntou was a village called Shuangjuntou Village, belonging to Zhilan III Bao. Although the water quality and quantity at Shuangjuntou Spring were slightly better than those at Shuangjuntou, at that time, in order to save construction costs, they chose to utilize the headwater at Shuangjuntou, which was closer to the Tamsui town. Taiwan's water supply construction began in 1895 when Tamsui and Qilong were important ports for the Japanese coming to Taiwan and served as bases for supplying food and drinking water to the Japanese military. At the beginning of the Japanese occupation of Taiwan, there were 164 deaths in battle, but the number of deaths from diseases was as high as 4,642. The Japanese believed that drinking water was the source of the epidemic. To improve environmental hygiene and address the military water supply issue, priority was given to the construction of waterworks projects in Tamsui and Qilong ports. In August 1896, the construction of Taiwan's first waterworks project commenced in Tamsui, marking the inception of a public water supply system on the island. In 1896, Goto Shinpei appointed William Burton as an advisor for the Governor-General's Office on Public Health Engineering. Burton, along with his Japanese student Hamano Yashiro, began conducting sanitary investigations in Taiwan. In 1897, he proposed a design proposal for sanitary works in Taipei and other areas, and participated in the design and construction of the Tamsui Waterworks, which brought water from the Shuangjuntou Springs to the urban area of Tamsui for public consumption. It was Taiwan's first water supply system, confirming the correctness of the earlier choice made by Danish engineer E. Han Sun. In August 1899, Burton contracted an infectious disease during his investigations, ending his short life of 44 years. During his final 3 years, Burton completed the investigation and design of the Tamsui Waterworks, Qilong Waterworks, preliminary plans for Taipei's Headwater Point Survey, headwater surveys for Taichung and Tainan Waterworks. His contributions to the establishment of Taiwan's water supply system were remarkable, laying the foundation for public health in Taiwan. His unfinished mission was carried on by his disciple Hamano Yashiro. The Shuangjuntou Springs, a natural spring that has lasted for 100 years, has clear and good quality water, eliminating the need for sedimentation and filtration facilities. Through underground conduits, the spring water is transported to the distribution reservoir and naturally flows down by gravity, automatically supplying water to the urban area. The water supply network consists of nearly 7,000 meters of water pipes buried along the route. Additionally, near the Overcoming Difficulties slope of Tamkong University, there is a water valve chamber equipped for the purpose of boosting water pressure, effectively delivering water to the urban area of Tamsui. In the early days of the water supply system, water was not delivered directly to households. Instead, vertical fire hydrants resembling public mailboxes were installed in suitable locations throughout Tamsui. Tamsui residents would go to these hydrant locations to draw water for their use, and these hydrants also served a dual purpose for firefighting. At that time, the average daily water supply from the Shuangjuntou Springs was 6,389 cubic meters, and the population of Tamsui urban area was approximately 7,000 people, plus the water supply for the military and ships, resulting in a planned water supply population of around 13,000 people, with a maximum daily water consumption of approximately 2,437 cubic meters. The remaining water was supplied for irrigation of approximately 70 hectares of downstream farmland through distribution gates. During that time, the water supply range from the Shuangjuntou Spring was quite extensive, providing for the entire Tamsui region. Until today, the Shuangjuntou Spring remains the most important source of domestic water supply for the Tamsui region. Above the entrance gate to the Shuangjuntou headwater point, there is an inscription that reads Tamsui Sui Yuan. Upon opening the iron gate, above a classically designed stone archway, you can find the 4 characters Hui Shui Yuan. The present-day Hui Waterworks belongs to the low-altitude natural groundwater source and is situated in the foothills of the Shuiyuan Street in the Tamsui district. It holds the distinction of being Taiwan's first water supply system. The Shuangjuntou Springs facilities have been designated as a historic site, covering the headwater, water valve chamber, fire hydrants, guardroom, brick columns at the entrance, and other related facilities. Furthermore, within the courtyard stands a century-old camphor tree, acting as the guardian spirit of the Tamsui Springs and faithfully witnessing the passage of time for this headwater. During the early 19th century in Taiwan, the sanitary conditions were extremely poor, and epidemics were rampant. During the Qing Dynasty, Liu Ming-chuan, and during the Japanese colonial period, Goto Shinpei, both made great efforts to utilize sanitation experts, dedicating themselves to the construction of public water supply systems in Taiwan. Among them, the Shuangjuntou Springs facilities have stood tall for over a century, with clear and delicious spring water flowing continuously throughout the year. Its significant contribution in preventing the spread of epidemics and promoting the prosperity of the Hui village back then was truly remarkable. Even today, it remains a crucial source of fresh water in the Tamsui area, making it truly precious. Among various public infrastructure projects, the construction of water supply systems holds historical value as cultural assets and should be properly preserved. This enables people to appreciate the source of drinking water and constantly remember the challenging history of development by our ancestors.